says analyze the rational functions graph below. I'll zoom in a bit so you can see better. Maybe. Still pretty bad. Okay, so what you're supposed to see in this graph are a few things. You're supposed to see two pieces that almost look symmetric, right? Almost look like origin symmetry, perhaps. And the reason I say that is because you have a point when x is positive 1, when x is positive 1, y is positive 2. But when x is negative 1, y is negative 2. So that part looks like origin symmetry. But then here we have a hole. We have a hole at 2, 1. So at the x value 2 and the y value 1, at that location there is no existence. And that was because a factor canceled. Okay? But if you were to change the sign to negative 2, you'd be at negative 1. We would expect there to be a hole there if there was origin symmetry, wouldn't we? But that's not a hole, that's a closed circle, so it exists there. So I already know there's no origin symmetry because they would have both had a hole or they would have both been filled at that location. Okay, so there's no origin symmetry as lovely as this picture is. I also wanted you to see two things in the graph. One is a break in the graph. There is no existence at x equals 0. So in addition to this x value 2 where you don't exist at that location, you never exist at the x value 0. So that must be that there's an x in the denominator that doesn't cancel. Then we have this horizontal asymptote, y equals 0, which means that the numerator's degree must have been smaller than the denominator's degree. So as x goes to the left forever, y goes towards 0. And as x goes to the right forever, y goes towards 0. Okay, so let's see if we can answer some questions now. What x-intercepts, if any, do we see? None, right? There are none. Very good. The answer there is none. There are no x-intercepts. I better scoot out a bit. There are no x-intercepts. The next question is asking you about what's happening as you go in certain directions, right? The first question says, as x goes toward infinity, so to the right forever, where are your y values approaching? Yeah, as x goes to the right forever, wouldn't that be this piece?
Yeah.
What are your y values approaching? Well, if the asymptote hadn't been there, I would have agreed with you, potentially negative infinity. But in this case, that asymptote is actually what you approach. So the idea there is like maybe maybe this graph is something like 1 over x, something similar to that. So as x is getting bigger, like 1 over 1,000, 1 over 1,000,000, you're getting closer and closer to 0, but you're not actually hitting 0. That's the idea there. So this would actually be a 0. We'd call that a horizontal asymptote, wouldn't we? That's our horizontal asymptote. What about as x approaches negative infinity? Same idea, right? As your x values go to the left forever, we're approaching that horizontal asymptote of 0. That's the definition of what we mean by a horizontal asymptote. This is how you're going to be writing it moving forward in math. You write horizontal asymptotes by thinking, as x goes to the right forever, and as x goes to the left forever, are you approaching the same y value? If you're approaching the same y value in both directions, it's a horizontal asymptote. That's what we mean by horizontal asymptote formally. As you go to the left forever and to the right forever, are you both going toward the same number? The same number. It's not like a polynomial. Are you both going up forever or down forever? It's different. It's a number, a fixed number, if it's a horizontal asymptote. Okay, we've talked about this notation already. See if you can answer this one. As x approaches, that's 0. As x approaches 0, and then this negative superscript, what is that saying? As x approaches 0 from the left. As x approaches 0 from the left, what is y approaching?
0.
So as x approaches 0 from the left, it's going toward what? Negative infinity would be correct. What about as x approaches 0 from the right? Good job. Positive infinity is correct. See if you can write the domain and range yourself for a moment. Keep in mind your asymptotes and holes.